So this is part 2 of the video on lesson 1.3. We finished the last part of the video looking at the integer division, and now we're going to look at how you can use a cast to avoid an integer division. So these two print lines that I have here both contain a double cast. All right, so I've put the word double into a set of parentheses, and it actually has to go onto the left side of that quantity. So in this case, it's the number 9. What that's going to do is that's going to actually change this number 9 into a double type quantity instead of an int. So as far as the computer is concerned now, it would be like the number 9.0. And so when that change occurs, that's going to result then in 1.8 for our division, not like earlier when we saw the number 1 appear. Okay, so that 1.8 that I have highlighted right there, that came from this line of code. Now, below that, I'm not sure how clear the video is on your end, but this is a 1.0. And the reason that that's a 1.0 is because I attempted to cast this to a double division, but I kind of messed it up because when I put the parentheses around the 9/5, what that did was that sort of distorted the order of operations. And so that division actually took place prior to the cast taking place. So again, the order of operations is very specific, and it can get pretty tricky at times. But just like in math class, parentheses tend to always come first. So, and not the parentheses of the cast, but the parentheses of the math operation. And so what happened here was when this division took place, it still saw 9 and 5 as ints. And so the division resulted in an int. And then that int was cast to be 1.0 written as a double. Okay, so that's why we see 1.0 occur in this second example, even though we were probably trying to cast away from it and get 1.8. So you got to be careful where you place that cast. And you can also cast within a variable value, so it doesn't have to be like a print statement. Okay, and we can also cast more like an older fashioned way here, just make it a double, right? Just say 3.0. The integer division only occurs when it sees two integers on the division bar. Okay, so remember earlier we were seeing 3/4, and we were kind of surprised by the 0, which then printed as 0.0. In both of these examples here, we should see 0.75 print. Okay, and here we're seeing 0.75 print because of the cast that I performed on the number 3. And here we're seeing it because I used a double. Once a double's been introduced into the operation, it's going to take over. We say that the more precise variable takes over. And so in this case, the double sort of wins over the int. It's more memory, it's more precise. And so the math operation ends up being carried out in double instead of int. Okay. Another thing introduced in 1.3 is the idea of a swap. This is another thing that we're gonna come back to over and over throughout the year, but it is introduced for the first time here. I've got two int values, a and b. A is initialized to 10, b is initialized to 20. And this is legal. You can initialize and declare multiple values at once. You separate them by a comma as opposed to a semicolon, which would terminate the statement. And so if I were to print right now a and b, I'd get 10 and 20. I'll explain more about this in my next video. Okay, I know it's a little bit strange how I have that space character there. Actually, we'll learn more about that in chapter 2 as well. We learn more about strings. So 10 and 20 have printed. Okay. And now if I wanted to swap A and B, it's a little tricky. It's not as easy as just, I think like the common mistake that a student would make would be to say A equals B, B equals A. That doesn't actually work. I'll show that to you in a minute. Instead, what I've done here is I've brought in sort of a third, placeholder, and I just named it temp, like temporary. Remember how Java flows from right to left. So what takes place right here is that a new variable named temp is declared and initialized, and it now holds on to 10, okay? At this point, I give B's value to A, because again, remember, data flows right to left. So 20 flows to A. So now A is holding a 20, so's B. Temp's holding a 10 though. And so if I then gave temp's value to B, okay, from right to left, now I've completed the swap, and now B holds 10. So on the second print line, we should see 20 space 10 because that swap took place. All right. So as I was saying, I think, maybe a common trap that a student might fall into is like if I told them to swap the variable values, they might write simply A equals B, B equals A. This actually wouldn't result in a swap. What would happen here, and this is kind of strange, is that now both variables would be worth 20. So we won't see 20, 10 on the second line. We're going to see 20, 20. And what happened to the 10? The 10 got lost right here because when I gave B's value to A, at that moment, A was holding 20. A variable can only hold one value. B is also holding 20 because remember, data only flows from right to left. So this line of code only changes the value of A. It doesn't affect B's value. So at that point in time, both A and B were holding 20. And so this line of code then just became kind of silly because I was simply giving 20 back to B, which it was already holding anyway. And so that's how they ended up both holding 20. So if you wanted to see like how to properly swap between two primitive ints, this is what we could do right here. And then another thing introduced in this chapter that's a little bit strange is like the idea of modulus and division to break apart a number. So there's an example that you'll see on the AP Classroom that uses modulus 10 and division 10 to reverse the digits of a number. That's a great algorithm that we'll come back to over and over. And I just decided to put like a slightly different example in here for you to consider. So a lot of times we work in things that aren't base 10. Base 10 is the number system that you've used your whole life. But, not everything works that way. Like, for example, there's 24 hours in a day. There's 60 minutes in an hour. So sometimes we think of things outside of just straight base 10. So, for example, if my friend told me he worked 103 hours and I thought to myself, wow, how many days is that? I could pretty much figure it out as a human. Like, okay, so I know there's 24 hours in a day. So that's like a little bit more than 4 days. But how would you get a computer like to do the math on something like that if you didn't know this value? Like you'd have to start maybe subtracting 24 over and over until you got to a point where there was like less than 24 hours, and that would be kind of your remainder. Well, that's where division and modulus come in real nicely. So if we took this number 103 and we divided it by 24, and you got to keep in mind right now, what's interesting is both of those numbers are ints. So you're not going to get a decimal here, even though this isn't an even division. I know it's like 4 point something. I don't really know what that something is. I could figure it out. I could get out paper and pencil and figure it out. But 103 divided by 24 is 4 point something. And Java is going to throw away that point something. It's just going to put the number 4. And that's correct. My friend worked 4 full days. But there were some hours left over, and that's where the modulus comes in. The modulus would give me the remainder of this division. So whatever wasn't taken up within those 4 complete 24-hour days, there's a little bit left over. That's your remainder, and that's what would show up by this modulus. So if we broke up that number 103 this way, we would then see how many complete days my friend worked and how many hours were remaining. And so a lot of times when we work, especially with time, because time, you have 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. A lot of times we end up breaking things up by bases of 24 and bases of 60. So this is something, we might see again sometime. And again, don't forget about the 2 links. And by the way, if you haven't figured it out yet, like in the description of my YouTube videos, you can get links to all of these replets as well, so that you can follow along and try experimenting with the code as well.